And welcome to another tutorial. So this time we are going to be continuing to expand on the biome-based procedural generation, and in particular we're going to be doing a couple of key additions. One is we're going to be setting up a height modifier that's able to generate more sort of island-based terrain, and the other thing we're going to do is we're going to set up so that we can more easily plug in different processes for actually generating the biomes themselves. So we're going to expand that quite a bit. So let's dive on in. Now, first thing I want to do is actually set up for being able to modify the height. So under the height map modifiers, I am going to create a new one that is going to be height map modifier, and this is going to be islands. So the idea behind this is that it's going to be able to generate more sort of islandy style terrain. So then under data, and I'll need to set this up under the height modifiers, I'm going to duplicate the initial one here, and I'm going to have this be initial islands. So I'm going to get rid of the noise script that's there. The initial sort of height that I'm going to set for this, because we do want to give some height to the terrain, I'll probably set that fairly low, so below the actual water height. And then we'll have our islands one, which then we can start to actually configure this. So how I want this to work is I want to be able to have control over how many islands get placed, and also have control over sort of the size range for those islands, the height of them, and I'm not too worried if the islands intersect. That's actually okay and could result in some really cool looking terrain. It's more just about making sure that it's got the shape and things like that of the island the way that I'm after. So this is going to inherit off of our base height map modifier. And I want to get in a few sort of key settings here. So one of the ones is going to be the number of islands to generate, which I'm going to restrict that to between 1 and 100 islands. Now we'll try to generate that number, but because we're going to keep it fully sort of random with the location, there might not be that exact number there. Plus, they're also going to be different sizes and shapes, so once they intersect things like that, we won't necessarily have that sort of full size. Then I need a bunch of ones where I'm going to have the min island size, and I might make that 20 meters. I want to have a max island size, and I might go for that being, let's say, 100. So that's the radius that will be. So I might actually make that a little bit smaller, maybe 80. Then I want to have things like the height. So that a minimum of 10, and this is going to be above the water height. So that's something we do want it to be above the water height is what it will generate. And then the max island height, well, I don't necessarily want them to be too high, because I might actually go for like a 40, because we do have a lot of other modifiers that run afterwards that mess with the terrain. So that's a good sort of starting point there. I do also want to, for controlling the shape of the islands, I want to actually use an animation curve for that. So island shape curve. So this will be not exactly the cross section, I'm not sure what the particular term for it is, but essentially a rough shape that will then rotate around and use as the shape for the island. So I'm going to make all of these serialize field. That's good. Now I will need to bring in the actual execute function from this, so I can be easily modifying the heights. So that's the main one that I have to bring in. So okay, what we want to do is we need to place our number or place our individual islands. And so what I'm going to do is up to the number of islands. So for island is less than num islands, I want to then have a place island, and we're essentially going to, it's going to have, we'll probably be able to remove some of these. So we'll have a void. And this will be place island. So initially I will pass in everything. So config, map resolution, height map we'll definitely need. Height map scale we'll almost certainly need. I'll just for now pass in everything. And we may end up not removing the ones that we don't use just because later on it might be handy to actually have some specific stuff there where we are using some of the things we're not using. Likely the biome side of things we won't use. So let's override. So okay, well I want to keep the size of these random. So okay, our working island size. And so we need to remember our island size. Actually, when we're placing things, we're placing them, we're iterating through the height map. So we're actually working on an integer size there. So I'm actually going to have our working island size. First set to a random range between min island and max island size. And then I need to convert this from meters over to our height map coordinates. So I can do that by, I just divide by height map scale x. And then what I'm going to do is a mathf round to int, like that. Now the island height, similar process, but in this case, we want to switch to our height map heights. So we want to switch to ones that are going to be between 0 and 1. So our working island height. Firstly, we do our random range between min island height to max island height. And then what I want to add in is global config and the water height, because this is the height above the water. Then I can convert that to our actual 0 to 1 range. So do that by a divide by our height map scale dot y. That's good. I've got the working parameters there. Now I need to pick where this is going to be. So, okay, center X. Well, that's going to be a random range between 0 and map resolution. And the center Y. So we do allow an island to be at the very edge of the terrain. We do the same for the Y. Now, if we wanted it that it couldn't be at the very edge, what I could do is rather than using 0, I use working island size. and I reduce this by working island size. That way, we're enforcing a buffer around it, so it won't be able to be at the very edges. So we can get a full island appearing in the actual setup. So that's good. So then, well, what I need to do is island Y, and this is going to start at minus working island size, and island Y is going to have to be so it's less than or equal to working island size. And then we update the island Y. Now to get our true Y, we do center Y plus our island Y. And then because that could be an invalid location, unlikely, but if we did end up removing these, we could get invalid ones. So just to make sure we've got the safety checks in there from the beginning, if Y is less than 0, or if Y greater than or equal to map resolution, then we skip. Then that loop, we do almost the exact same thing, except everywhere where it was Y, we do X. This makes it a little bit easier and cleaner. So that's good. We're looping over the entire island. Now we've got this curve that we'll be able to draw, and that curve corresponds to the bounds of the island. So we need to actually know the normalized distance of this location to the center of the island so that we can actually work out where on that curve we need to be. So, okay, our normalized distance, what we do is we've got our island Y and X, which are our offsets. So those we can use as the basis for this. So we can do a mathf square root island X by island X plus island Y by island Y. That gives us, at the moment, just the distance, but if we divide this by island size, that's our working island size. And this is a float, so this will get converted to a float as well. So okay, that should give us our normalized distance. Now, because we're iterating over a square block, bits in off the four corners, that would be a normalized distance greater than 1. So in those cases, we actually don't want to do anything with this. So if normalized distance is greater than 1, we skip, because we want to be generating a roughly circular island. So that's good. So, okay, to get the height then, our height is going to be the working island height that we've chosen here, multiplied by, we take our island shape curve and we evaluate at that normalized distance. So the important thing with this when we lay out that curve is that 0 on the time axis corresponds to the center of the island. So that should actually be the highest point, and 1 should be the lowest point. So that gives us our normalized distance. So then we can say height map xy is equal to, I'm going to actually go for the maximum of the height map, the current value, and the new height. We could have different ways that we blend that, but for now I'm going to go for the maximum, and we'll just see how that looks. Because at the moment the islands also we don't have any variation of them. They'll be the consistent sort of shape that gets rotated around. So we might want to go and do some further modifications there with that. But what I will do is I will switch this over to using the new island-based one. And then with that, can regenerate the world. We just want to see how that initially looks. So that's not bad. We've got definitely more islands appearing there, which is good. We haven't actually set up the island curve, so that's something where we should make sure we modify that now. So with this, I'm going to start with the normal S-curve that we have and edit the points here. Swap them around. So remembering 0 point here on the time axis is the center of the island, and then we have our edge of the island here. And I'm actually going to change the shape a little bit. What I want it to do, so I do want it to sort of fall off like that. But I want to have a bit of a sort of, I guess, different shape to that fall off. Something like that, I think, could be good. And this is something we could easily mess with quite a bit. But I like that. And maybe the top part of it here, we could say we want that to be a little bit flatter for longer. Something like that. And then that looks good. So let's regenerate that again. So that looks good. We've got a lot more islands being generated there. It's obviously the texturing happens later, so that's why initially the texturing looks quite off. So that's good, but very uniform in shape. So what I want to do is I want to add some noise to this. And as we effectively rotate this around, I want to add a different amount of noise. So what I'm going to do is I'm going to have angle noise scale, which I'm going to initially just default to 1, but that's something we can easily mess with. I'm going to have a distance noise scale. So we'll apply noise both on the actual angle and the distance away from the center point. And then let's have an actual amount for that noise. So noise height delta. And let's say it can maybe, we don't want a huge change. We don't need a huge change. So I think something like 5 meters is probably enough. So that looks good. So what we can do then, well, we've got a normalized distance. We can get our normalized angle, because what we can do is a mathf atan2, and we can use our island y and island x, and then if we that could give us a range between sort of minus pi and pi. So what I can do is I can add mathf.pi to that, divide that, mathf.pi, and I will clamp that to between 0 and 1. So that gives us something that should be normalized. Actually, that should be 2 times. That. So that will give us our normalized angle. So then our noise value, what we do is we do a mathf noise, And then it doesn't really matter which one we use for X and which one we use for Y. But I'm going to use the normalized angle times by the angle noise scale. And I'm going to use the normalized distance by the distance noise scale. So this way, it's something that is still uniform, so we get that nice flowing of things together. So we get smooth transitions with the noise, but we still get something that varies around the entire shape of it. We're just working essentially in angular coordinates for it. So that should be good. That gives us the noise. So then our noise height delta, well, our noise is going to be between 0 and 1. And I want this to be able to raise and lower the terrain. So what I'm going to do is our noise minus 0.5 times by 2. So that now is going to be between minus 1 and 1. And I want to multiply that by our noise height delta, which, because it's in meters, I need to divide that by our height map scale.y. And then our height, we add the noise height delta. So what I should find with this is they're not as uniform then, the islands that get generated. So let's regenerate that now, and we'll see what we get. So we do notice there is a bit more variation between them. We could adjust and ramp up the noise height delta, things like that, so that we get a bit more of a variation there. We do see them merging together, which is good, and that definitely sort of helps with it. I think I can probably get away with ramping up the noise height a little bit more. Whoops, no, do not replace. So the noise height delta, let's actually ramp that up to 15. Generate the world. That looks a little bit better, a bit more variation there. Again, we could apply still a little bit of noise over the top of that, because we did entirely remove the default noise that was being applied. So we could bring that back. So this initial islands, so I could paste that in. Now, because of the order, it will run after the islands have run. So let's see how that looks. I do like how we get things like this sort of carve out here because of the terrain, or because of the objects that's been placed. I think that's quite nice. So that, I'm quite liking how that generation is sort of looking there. We're getting a bit more interesting shapes. We get these little chains of islands, and I am generating quite a few islands with this. We could do stuff where we are combining both the radius of the island and also the height, so that there's a bit of a ratio that has to happen there for it. But I do like that we get little sort of carve-outs here like this. I think are particularly cool. And we get little sort of hidden areas like this. So I think that's quite cool how it ends up looking. So we've got our generation of islands happening. And our beautiful, I'd forgotten that there was a section with red grass in it, but we have our section there with that, which I think looks quite cool. So the next part we want to look at is we want to now make it so that we can generate different biomes, because we have support for being able to modify the height stuff that's used. We don't have any support for being able to change the biome generation though, and that's something that I think is really important. So I'm going to create a C# script here, and this is going to be our base biome map generator. And then we're also going to have one that is for our current one, which we're going to bring over. This is our biome generator ooze-based. So that's good. We have those set up. What we'll do is, and I put those into the wrong folder, put those into the actual scripts folder. I will create an actual empty prefab here though, that does have that on it. So let's set up our, here's prefab. So biome generator ooze based, and that will have our ooze based one, but it hasn't actually picked up that script. That's quite odd. It's definitely got that there. May not have actually gone and recompiled the code, so that might be why. So we'll just actually do this. Should kick off a recompile. Looks like Unity's gotten a little bit confused. So that should allow us now to add in. There we go. So yeah, Unity got a little bit confused with what stuff was there for it. So okay, let's look at getting this set up. So this is going to be our base one. And we want to take a look at what we want to extract for this. So where this all gets done currently is in the ProcGen manager. And we have these low and high resolution biome map sections, which I'm going to just change that to build biome map for two reasons. One, our different methods that we use might not actually have low and high resolution ones. The other reason for it is it makes it really easy to track down where we're running the stuff in the code, because we can easily see the areas that break. So now this becomes build biome map. So I can see I've got low resolution and high resolution. So those are the two functions I'm looking for, and that I want to move over. So what we're going to end up having is perform biome generation, and I'm going to make it so that it's kind of a blend of both of these. So rather than passing in the biome map resolution, I'm going to pass in the config itself, and then the biome generator can access it if it wants to, rather than forcing a particular interpretation of that low and high resolution. So, okay, we've added that in. So we're adding in a bunch of things that are going to be causing errors, which is fine. Now, low resolution and high resolution, I am going to take these functions and actually all of the bits associated with it, because they're all conveniently in one block. And I'm going to grab those and bring those over to our ooze-based one, because that's going to help tell us what breaks and what data we also need. So these biome maps, well, those are things that we clearly need to be passing through. I'm also going to set up here my biome generation function. And I might actually, the config, yeah, other ones don't pass through the config, so I think I'll change it so that up here we're not passing through the config. Good. I have gone and accidentally deleted a little too much. So we'll just make sure I bring back the height generation 1, because I've got the building of the biome maps, and then the height map modification. I accidentally removed that, so we're just going to bring that back. There we go. So, okay, the low resolution ones, well, that's very specific to how the ooze-based one works. So that, I'm going to bring those variables over to the ooze-based one. Now, they're likely going to have an execute function very similar to what we have in these other ones, but they won't have all of the same parameters. So let's start to figure out what we kind of want parameter-wise. Config makes sense. Things like height maps, stuff like of that, biomes, none of those are ones that make sense for this. So we'll get rid of a lot of those. But it does have stuff like this biome map and the biome strengths. So those I will bring across. Because those look like ones that we do want to actually have as part of this. Let's rename those so they follow the same conventions. But that looks pretty good for a set of ones that it needs. The biome map, the biome strengths. We likely shouldn't need much more than that, but we can easily add in other ones if we do need it. So that's good. That gives us our main function that we would have in our ooze-based one. So we're just trying to get things to the point where it's essentially working the same way that it did before. So, okay, we want to be able to do the perform biome generation low resolution. And we have our map resolution. Now that wasn't actually the map resolution. That was this we had from the global config. We had the biome map resolution. And that's something that, because this is very specific, and these were all very specific to the ooze-based generation, I'm actually going to remove those and bring them over to here as configuration parameters. Because they don't really make sense as being ones that are sitting elsewhere. So we can actually then go int biome map resolution. And then we want to do the perform for the high resolution ones, which again, we give it the low resolution. We need to then give it the map resolution, so we need to give it the low and the high ones. We're going to, in both cases, well, at least in this case, it's going to need the biome map and the biome strengths to be writing to. So it's going to need to know that. We need to probably, looks like, pass through the config. Actually, no, we don't need to pass through the config because that's seed point density. We have as a internal parameter now. So I'm getting most of the way there. It's not too much more that we need to change. We're just looking for things where, okay, the number of biomes, that's one where we are going to need a little bit of information through. This one where we've got configuration, we're going to need some stuff with that. So there's a couple of ones that we're going to need extra info passed through. Now with this, the biome map and that, it would be allocating it in here. I'm actually going to move that allocation, the actual setup of it, into here. So it makes sense for this to control the size of this, because it's the one that's then using it for everything else. So it makes sense. So these can go and modify it, but they can't go and be reallocating it. So we don't have too much that we need to update. We're going to rename these to texture. So that's looking good. We do need the config coming through very clearly for quite a few things. So we're going to have procgen config like that. So a few things are going to be expecting that. We're going to likely find the exact same for the low resolution from memory because it was doing similar stuff. And I'm just renaming this just for consistency so that we're following similar naming convention in both. So that looks good. It changes to, all of these ones change to config with a lowercase c, and we pass that in. So then we have global config, and global config like that. So it's looking pretty good. We don't have any errors, it looks like. So spawn individual biome is going to need the config as well. So we'll have another change for the low resolution one when we're doing that spawning of the biomes. But otherwise, that looks like we're in a pretty good spot. This one's nicely updated. Now we just need to really actually change this so that we're running it. So similar to what we did with the having initial height modifiers, we want to actually have a biome modifier. So these would be base biome map generators. We'll change that in a moment. If that looks good, we pass in the config, the map resolution, the biome map, and the biome strengths. And then rather than initial heights, this will be biome generators. Just so we're accessing the right thing. This I'm going to rename to generators just so we're consistent. And then in our config, we just need a public game object for the biome generators. So this should now mean that we have an easy way of being able to swap in and out different biome generators for the game. Okay, so we're now ready to link up our biome generator. So we can link that up. And then if we go and regenerate the world, so it will have gone through the same processes there in terms of still using the island-based one, but we've now got it running the different biome ones, so we get a little bit of a different shape there for it. And actually I turned off the island one, so just to make it easier to see the biomes, but that's that biome generator working. What if we set up a different biome generator? So I'm going to do a very, very, very basic Voronoi-based generation. So I won't duplicate the use-based one. What I'll do is I will create a new one. Now this is going to be very basic, but we'll have biome generator based. Do set that up. Now because we've made it so that these are actually modifiers, we could now easily set up a biome generator that modifies existing biome, like existing data that's already been generated. So we get the advantage of being able to stack them, which is very cool. I'm going to switch the config over to using the Voronoi-based one. And then let's set up the code for this. So base biome map generator to begin with. We're going to use this as our starting point. Now, the idea behind the Voronoi-based one is what we will do is we will pick a bunch of locations to and pick a random biome for them, and then we will go and pick random locations, and then for each cell essentially in the biome map, we pick the location, pick which seed point it's closest to, and that's the biome it becomes. That's sort of the very rough version of the Voronoi-based setup. So it is going to be a very rough implementation of a Voronoi-based one, but it will get us what we need. And what I'm using as a bit of a reference point for this, and I'll bring this over here, is the run through on this website. So it's based upon the stuff that this one discusses in terms of being able to sort of apply a little bit of jitter, things like that to make it work nicely. So what I'm going to do is I'm going to divide up the world into a grid. Now, because the map resolution is what it is, not all of these cells are going to be the same size. That's okay. Just adds a little bit of complexity to what we need to do. So I'm going to say our number of cells. So probably a good initial value for it, I'm going to actually go with 20. So what I want to do is, okay, work out the size of a individual cell in terms of what it is as part of the map resolution. So I'm going to do a mathf, and I'll round up, I think is the appropriate one in this case. Float of our map resolution divided by the number of cells. So that's good. So then I want to generate the biome seeds. So I'm going to actually use a vector3 int for this. Biome seeds. It won't be cell size, it'll actually be num cells by num cells. So that's good. Then what I'm going to do is cell Y, that. And we do the exact same thing with cell X. And what I do then is I'm going to pick a location and I'm going to pick a biome for it. So int cell index is going to be cell Y times our number of cells, and we add cell X to that. So what we're doing is generate our seed points. So, okay, for each seed point, so biome seeds, cell index. Let's do the easy part first, the actual biome itself. So that's going to be a random range from 0 to our global config num biomes. So that one's easy. Then we have our X, cell index. So this, it should be a random location relative to the particular cell center. So what I'm going to do is center X is cell X plus 0.5 times by our cell size. Do the same thing for center Y. Now it's okay. This will actually be a location that is outside of the map for likely the ones at the very sort of edges, just because the cells aren't going to be uniform in size. And that's okay. So we do a mathf. I'm just going to do a round to int, because these locations can validly be off the map. That's actually all okay. The center Y calculation, I'm going to move up to here, just so I'm not doing it as often, making it a little bit more efficient. So, okay, we've got our location. I want to apply a little bit of jitter to that, and I want each time that jitter to be different. And this is one of the techniques that's mentioned here in this site that's really, really handy. So definitely worth checking out. It's really, really in-depth. I'm using the tiniest fraction and a simple version of the stuff that they're talking about there. If you're really interested in procedural generation, highly, highly, highly recommend checking it out. I'll put the link in the description as well. It's very, very cool. Very much recommend it. As someone who's really fascinated by procedural generation, it was a very, very interesting read, the techniques, and it's very well explained. So we want to do the center X plus, and this is where we apply a random jitter based upon, and it can be minus of the cell size divided by 2 up to cell size divided by 2. And we do the exact same thing for Y. So each point is able to be moved around a little bit. So it means we get a bit of a distorted shape to it, which is actually really good. That's what we want. So, okay, good so far. Then what we're going to do is we're going to generate our initial biome map based upon this. So generate our base biome map. Now we're going to create a copy here, and the reason for that is because this is our rough initial seed one. Similar to how the ooze-based had a low and a high resolution, we have 2 high resolution ones. We generate one and then we resample that to get a bit of variation to it. So base biome map. So it's a new byte. And we have, this will actually be map resolution by map resolution. Then what we do is we loop over it. So our, by now, very familiar process of this same loop that we have written. By this point, I have lost track of how many times I've written this. And honestly, across all of the different projects that I've done, this is just such a common thing that I end up writing. It's something that I swear it wouldn't surprise me if in my sleep I just am typing out this loop with how often I just end up writing it. So, okay, the base biome map for our X and Y. What I want to do is I want to find the closest biome. I want to find the closest biome to this location. I need it to know the number of cells that it's searching between. it's likely going to need the cell size, and I need the biome seeds. So what this function does is it has to go and look through the biome map to find whichever one is closest. So it returns a byte, find closest biome, X, int Y, int num cells, int cell size, and vector3 int of biome seeds. So what I want to do is I want to search and find which of the biome seeds we're closest to. Now, I could have a lot of biome seeds. I don't want to have to search all of them. But because we've gone grid-based, I actually only need to search my neighbors around me. So I only need to look at the seed for the 9 cells around me, and also the cell that I'm currently in. So I only need to check 10, as opposed to checking your FO with the current number of cells of 20. That would be 400 cells. So rather than checking 400, I check 10. That drastically lessens the amount of stuff I need to check. Part of the way that I'll be able to do that a little bit more easily for finding neighbors, and this is something where I kind of am going to end up probably moving this to be globally defined at some point. Just because the number of times I'm going and checking the neighbors, it's just a constant thing. So, okay. So neighbor offset and neighbor offsets. Well, firstly, I need to know my cell X and Y. So cell X is going to be X divided by cell size. And cell Y is going to be like that. So that's good. Now I need to find the closest seed point. So float closest feed distance squared. So I can get the distance to the current one. So what I would be doing for that, we'll get to that in a second, because I also would store the best biome, which will default it to biome seeds, cell X, cell Y, and the Z value, which I need to cast that to a byte, so it's happy. And we just return that. That is cell X plus cell Y times by num cells. So the closest distance, well, I need to calculate the actual distance there. So what I would be doing is X minus, and what I might do is actually store this cell index. I could have organized the biome seeds to be a 2D array as well. You end up having, it's sort of a bit of a compromise either way. You're often having to do the similar calculations no matter what, so it doesn't make a huge difference. But I can go biome seeds, cell index, X minus X. Like that, and I square it, plus, and then I do the exact same thing with Y. So that's going to give me the distance to that one. And then all I'm doing is then checking the neighboring ones to see if any of them manage to beat that. So, okay. What I would end up doing is my working x is my cell x plus our neighbor offset.x, working y, cell y like that. I'm going to recalculate the cell index. Then I want to get the distance squared, but I want to first check if this is completely an invalid working x or that, because it could be. It could be right at the edge of the data and it won't be valid. So if working x is less than 0, or working y is less than 0, or working x is greater than num cells, or working y is also greater than or equal to number of cells. Again, something I've written many times. Okay, so then distance squared, I'm going to largely take this because we're already doing the right calculations for it. So our distance squared like that, because we're already recalculating the cell index. So then I can just check, well, if this distance squared is better than the closest one, then the closest one becomes that. And our best biome becomes, again, we just use, this actually should have changed to cell index, like that. So it keeps the code similar, which is good. Makes it easier in future. So that's good. And we'll find the best biome. So, okay, that should give us a initial setup where we have these biomes generated. Now, if I initially, what I'm going to do is I then want to save this out, similar to what I was doing in the ooze-based one. So I'm going to grab where I was doing that. Going to save this out. So, okay. This is our map resolution. Global config. Now this is Voronoi on the base one. So I just want to do this so I can make sure that the data is good before doing anything much with it. Because that looks pretty decent, and I've already got the setup here where I can see what the maps look like. This is what the ooze-based one, the high resolution one, looks like. So, okay. We can check and make sure our config is using the Voronoi-based, which it is. So let's regenerate this. So we've run this and we notice that looks all fairly uniform, which, there's no biomes being set. And if we look at the image, you might get an image that is looking more like this, where it's all sort of square. And that is because very easy thing to actually be doing. This should have been working X, and this should have been working Y. I'll actually rename those so it's a little bit clearer. So I was effectively doing the calculations always to the same cell, which understandably is not going to work so well. So with that fixed up, I'll just double check that we saved. And now we regenerate it. We should still, it'll look bland like this, but if we look at what the image looks like, this is what we expect it to seem and look like, this sort of shapes. So what we're now going to do is we're going to distort that so it doesn't have all of those sort of straight line edges is what we're trying to get rid of with it. So we're going to get rid of all those straight line edges, and how we're going to do that, and again, big shout out to the this reference site, which had a really cool reference for how to do this. What we're going to do is we're going to resample the biome map. So what I will do is our actual biome map. We're going to go resample biome map. We give it the X and the Y. We're going to give it the base biome map and the resolution. I'm also going to set up here so that we can define a resample distance. So essentially how far away it can pick. And I'm going to say maybe 20 to start with. So we'll also duplicate this and we'll resave out in this case, this will be the final one. Oops, let's make sure we rename the correct one. Just so we can compare what the two look like. So, okay, what the resample is going to do is it's going to essentially introduce some error into this. So rather than giving us the exact location, it's going to go and give us the biome for somewhere nearby, with it being slightly randomized. So, okay, we have our X, Y, and where did we provide the map resolution? The biome map and then the map resolution. That's good. So firstly, I want to calculate the noise. So that's going to be mathf for the noise. We're going to do a float X divided by map resolution. And same thing with it dividing it by Y, or for the Y coordinate. Now that gives us a 0 to 1. So we're going to subtract 0.5 from that and multiply the result by 2. So we get something that is from -1 to 1 again. So then our new X, well, that's going to be, I want to do a clamp because we want to keep it in a reasonable range. Mathf, because we're going to need to integerize it. Our X plus noise times by our resample distance. So we pick a location randomly up to that range. It has to be between 0 and map resolution. So that looks pretty good. We do the same thing for Y. Yep. And then all we do is we return biome map and at that different location. So we randomize where we're actually getting the data from. So that should remove some of those harder edges. So if we run that, so we got a error. We just want to check what we're doing here. So new X, new Y. We are clamping correctly. So it should be between subtype resolution. So the reason for that error is clamp allows it to go up to map resolution, whereas the actual max should be -1 on that. Easy to miss because so used to random ranges not being inclusive of the upper limit for integers. So now we regenerate it, and it's kicking off doing that. We can see here is our base one. On the final one, you can see there's a bit of distortion happening there to it. As we increase that resample distance, that will actually increase that level of distortion. So what I could do is up that to 100. Regenerate with that. And now if we take a look at our base and our final, it's much more distorted. And we could do a lot of other post-processing ones on this. You could run multiple cycles of that. You could have different ways that it's doing that post-processing there. Could also, because of how we've now set up the biomes, things like of that could be split off into its own modifier that then can be stacked with the other modifiers. So we can start to really layer things with the biomes as we need to now, which is really, really handy. So we have our biome generation now where we can configure and customize the modifiers. So dive on in and experiment with it. See what kind of effects you can get by layering some of those modifiers. And you could add in a modifier on the biome side that's doing blurring, that's doing other sort of things like of that. Could get some really cool effects. But dive on in and experiment is the main thing. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you have any questions, chuck in a comment below. And if you're looking for the code for the project, the code is available up on GitHub. There is a link to that in the description below. You can use the code in any of your own projects, commercial or non-commercial ones. No issues with using it there. If you are trying to track down other videos, I do have a searchable video archive, which I've put a link to that in the description. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below as well. But until next time, bye.